And here's what we're going to do. We're going to apply this to a graph. If I look at something like number 7, I'm going to find the same things I just found along with the end behavior in order to graph this thing. So I set each factor equal to 0. So I find out that x equals 0, x equals 3, and x equals a negative 4. All right? And now again, I'm going to list the multiplicity. The multiplicity of each of these is 1. They're all raised to the first power, which means all of these are going to pass through the x-axis. Okay? So each of these, I'll write pass here for passes through, instead of writing through each time. So it'll be a little bit shorter. So each of these is going to pass through. And then the only other thing I need to graph this thing is the end behavior. So I look at x going to negative infinity, and I look at x going to positive infinity. And again, I plug each of these in. If I plug a negative infinity in, I'm going to have a negative times a negative times a negative, which is a negative. If I plug a positive in, I'm going to have a positive times a positive times a positive, which is a positive. All right? And now when I plot this, 0 is right here somewhere, negative 4 is back here somewhere, and positive 3 is up here somewhere. And my end behavior at the far left, I know that my function should be going down because the end behavior states that as x goes to negative infinity, f of x also goes to negative infinity. As I go to the far right, positive infinity, my f of x should be going up. So now I know the ends of this thing and what they should look like. And then because of my multiplicity, I know at this x value of negative 4, I should pass through the x-axis. At 0, I should pass through. And at 3, I should pass through. So my function is going to look something like this. Okay? So that's how we use the x-intercepts, the multiplicity, and the end behavior to draw a quick sketch of these things. Number 8 is going to be this, very similar. So again, I set each factor equal to 0. I do the x equals 0. I do the x minus 4 equals 0. And I do the x plus 3 equals 0. And I solve each. So x equals 0. Here I add 4, x equals 4. Here I subtract 3, x equals a negative 3. And now the multiplicity of each of these, since the x was squared, it means the multiplicity of this first answer is 2. There's 2 of those x equals 0s. The middle one is to the third power, which means there would be 3 of this answer. Last one's to the fifth power, which means there's 5 of this answer. So the multiplicity is 2, 3, and 5 respectively. And what that tells me is that this first one that I found is actually just going to touch the x-axis because the multiplicity is even. This one is going to pass through the x-axis. And this one is also going to pass through the x-axis because my multiplicities are an odd number of multiplicities. All right? And then in terms of end behavior, I look at the end behavior again. So as x goes to negative infinity and as x goes to positive infinity. And we just have to be really careful with our signs here. When I plug the negative infinity in, essentially right here is where I'm going to make the mistake. Because it's negative infinity squared, which is positive, and then I tack on this negative sign. So I end up overall with a negative infinity times another negative infinity because of cubing it, times another negative infinity, which negative times a negative times a negative is a negative infinity. Okay? Same thing with the positive. When I plug this in, be careful with my signs right here. I plug a positive infinity in. Positive infinity squared is a positive, but then I tack on this negative symbol. So I get a negative infinity times a positive infinity times a positive infinity, which is going to give me an overall negative infinity once again. So again, we're just plugging this in and seeing what the signs turn out to be. And in this case, I should get a negative infinity each time. So now I plot each of these values. I've got the 0. I've got the 4 out here somewhere. And I've got the negative 3 is back here somewhere. The end behavior, as I go to the left, negative infinity, my function should go down. As I go to the right, positive infinity, my function should go down. And now I just use the multiplicity. As I approach the value of negative 3, I'm going to pass through because that's what my multiplicity says. As I approach 0, I'm just going to touch because that's what my multiplicity says. And then as I approach the next value, the 4, I'm going to pass through because that's what my multiplicity says to do. So I get something that has this kind of M shape. And again, this isn't completely accurate. We might have values that go up a little bit higher over here and maybe lower over on the other side, but we're just drawing a quick sketch. Now we know that there's a local maximum in between those two values and a local maximum in between the other two values as well. Okay? For these, we want to factor completely. Remember, when we're factoring these, we're using all the methods that we've previously used. For this one, since there's 4 terms, I immediately go to something like factoring by grouping. So I group the first 2, group the second 2. Out of the first 2, I can factor out an x squared, which leaves me with a 2x plus 1. Out of the second 2, I can factor out a negative 4, which leaves me with a 2x plus 1. So now my 2 factors are the 2x plus 1 and the x squared minus 4. But I want this to be factored completely, and an x squared minus 4 is actually a difference of squares, which factors into conjugates. One's a plus, one's a minus, so it's an x plus 2 and an x minus 2. And that's it. It's just asking me to factor. I'm not solving anything here. In fact, I can't solve because I don't have an equal sign. Scooting that over a little bit to give myself a little more space in the next one. If I look at the next one, this is quadratic in form. It's of the form something squared plus something to the first power plus a constant term. And really, just look at the exponents. Since it's an 8 and a 4, we're looking for the first exponent divided by 2 gives us the second exponent. So if I had a 6 and a 3, typically it's going to be in that format. So really, I just treat it like a regular quadratic. I build a bridge, 2 numbers that multiply to a negative 18, but add to a negative 3 or a negative 6 and a positive 3. And normally, when I was factoring a quadratic, it would be x minus 6 and an x plus 3. But that's when I had an x squared out front, and x times x gives me an x squared. This time I've got an x to the 8th, so I need an x to the 4th times an x to the 4th. So it becomes an x to the 4th minus 6 and an x to the 4th plus 3, and that's it. Okay, that one can't be factored any further. In number 11, we can factor out a greatest common factor, so I factor out the 2x squared, which leaves me with an x cubed plus 27. And now x cubed plus 27 is a sum of cubes, which factors into a binomial and a trinomial. And this is my SOAP problem. Remember, this is a plus sign, so the first sign is the same, second sign is the opposite, and the last one's always a plus. Same opposite, always a plus, SOAP. All right? The cube root of x cubed is x. The cube root of 27 is 3. And then I square each of these things. X to the second power is x squared. 3 to the second power is 9. And then the middle term, I multiply these 2 values from my binomials, the x and the 3, which gives me a 3x. Okay? Now this thing is factored completely, so I'm done. If I look at number 12, this time I want to solve, and I'm going to solve by factoring. Once again, I've got 4 terms here, which is a giveaway for factor by grouping. So I group the first 2 and the second 2. Out of the first 2, I factor out an x cubed, which leaves me with an x minus 1. Out of the second 2, I can factor out an 8, which leaves me with an x minus 1. So now my 2 factors are the x minus 1 and the x cubed plus 8. But of course, the x cubed plus 8, that is a sum of cubes once again, which factors into a binomial and a trinomial. This sign is the same. This one is the opposite. This one's always a plus. Cube root of x to the 3rd is x. Cube root of 8 is a 2. X squared is x squared. 2 squared is 4. The middle term, I do the 2 times the x, which is 2x. All right? And then this x minus 1 just kind of tags along for the ride. And since I'm solving this time, if I want to solve this thing, I just set each of these factors equal to 0. When I set x minus 1 equal to 0, I add the 1 to each side and get x equals 1. Here I subtract the 2 and find out that x equals a negative 2. Here, I've got 2 options. If I set this equal to 0, I either have to solve by completing the square of my quadratic formula. I'm going to solve by completing the square. So I'm going to subtract the 4 from each side. So I get a negative 4 here. And now I'm going to fill in this blank. Remember, I take this middle term, b divided by 2, and square it. So negative 2 divided by 2 is a negative 1. Negative 1 squared is a positive 1. So I add 1 to each side. And now x squared minus 2x plus 1 factors into an x minus 1 squared, equal to a negative 3. And now I can take the square root of each side. When I do that, I end up with an x minus 1 equals plus or minus I root 3, and then I can add the 1 to each side. So I end up with x equals 1 plus or minus I root 3. So these are my collection of answers. I've got the 1, the negative 2, and then the 1 plus or minus I root 3. And that's it. Okay, so we're using all of the methods that we've used previously to solve this thing. In number 13, this thing is quadratic in form because I've got a 2 and then a 4. Again, just look for that pattern. which means I'm going to factor it the same way I would any trinomial. I'd build a bridge, two numbers that multiply to a 4 but add to a -5, or a -4 and a -1. Which means typically this would factor into an x minus 4 and an x minus 1. But since it's an x to the 4th, it's going to be an x squared minus 4 and an x squared minus 1. And now to finish factoring this, each of these is a difference of squares. So this factors into x plus 2 and x minus 2. The next one factors into an x plus 1 and an x minus 1. And now I set each factor equal to 0. So this one I would subtract the 2 and find out that x equals -2. Here I'd add the 2 and find out that x equals 2. Here I'd subtract the 1 and get a -1. Here I would add the 1 and get a positive 1. So I end up with these 4 answers. OK? Number 14, the first thing I would do is factor out the greatest common factor. And I factor out the 6x. Leaves me with an x cubed plus 1. And then from here, I've got a perfect cube on my hand, a sum of cubes, which factors into a binomial and a trinomial. This sign is the same. This one's the opposite. This one's always a plus. So I've got an x and a 1. I square it to get an x squared. I square this to get a 1. The middle term is the x. Now I set each factor equal to 0 here. When I set this equal to 0, I find out that x equals 0. Here I find out that x equals a -1. And then this last piece, I've got to do my quadratic formula for. So I'm going to do x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And now I just simplify my quadratic formula. So I get a 1 minus 4 here over 2. So I get a 1 plus or minus the square root of -3 over 2. So we had x equals 1 plus or minus I root 3 over 2. So here's my collection of answers. And that's it. Okay. The last one, this is a difference of squares. And a difference of squares always factors into conjugates. So this is going to be an x squared plus 8 and an x squared minus 8. And from here, these don't factor any further, and that's OK. I set each factor equal to 0. Just be careful and write out these steps, or you might be prone to make a mistake here. But to solve each of these, I subtract the 8 from each side on this one, and I get x squared equals a -8. And then just solve using my square root. I take the square root of each side. So I find out that x equals plus or minus the square root of 8, which I can, sorry, the square root of -8, which I can break down into a -1, a positive 4, and a positive 2. And then I start taking the square root. The square root of 4 is a 2. The square root of a -1 is an I. And the 2 is still trapped under my square root. There's still a plus or minus out front here. And those are 2 of my solutions. Well, I got to finish solving this other one. I add the 8 to each side. And this is going to be very similar. I've got x squared equals 8. I take the square root of each side. So I find out that x equals plus or minus the square root of 8, which remember 8 is 4 times 2. The square root of 4 is a 2. It goes to the outside. He's a change number on the outside. So it becomes a 2 root 2. So this is my collection of answers. I've got 2 complex solutions and 2 irrational solutions. All right? That's it. Hope this was helpful. And good luck on your quiz.